Hello everyone, have a good day. We are the students of IES College of Engineering Chittilappilly, situated at Kerala. We are very glad to be a part of this event, Niyantra 2013, organized by National Instruments. Thank you Niyantra for having us for the second round. The project that we are presenting here is named as Highly Intelligent Elevator Control, Hiec. First of all, let us go through the introduction section of our project. Here we are explaining the importance of our project, how it is different from the existing system, or we can say the need of our project. Man always wanted more, need more. He always desired for comfort. The man's desire for comfort lead him to inventions and discoveries. From simple watt engine to complex aeroplane systems. Of course, elevators are one of such inventions. It also added humans' comfort. In a multi-storied building, elevators are crucial elements. Today, we have wonderful elevator systems, group elevator systems, but as I said, man always needed more. Today, he aims at maximum efficiency, that is, maximum output with least power and minimum time. So, efficiency is the prime motto of this era. Here in our project also, we are developing an elevator system, an efficient elevator system with reduced time and power consumption. As we all know, existing elevator system has several shortcomings and drawbacks like long waiting time, long riding time, high power consumption. And the solution that we are presenting here is Hiec, Highly Intelligent Elevator Control. Hiec stands for that. It is a control system for systematically managing group elevator system. It manages elevator system efficiently. The logic or the control scheme that we are using here is fuzzy logic. As we all know, the fuzzy logic is a branch of artificial intelligence. It can interpret and conclude like an human operator. So it is the fuzzy logic controller in the elevator system that is assigning an appropriate elevator or lift for each new call made. The most appropriate lift means a lift that can execute that call within minimum time and with minimum power consumption. The data regarding destination floor and the number of persons to enter must be given as input to the controller for finding the most appropriate lift. So the fuzzy logic controller will interpret the data and will find the most appropriate lift for that new call made. So this is the idea of our project. Now we are going to explain the implementation section of our project, that is how it is made practical. The main difference of our system from the existing system is about the control panel. In our system, we have only single panel outside the lift for controlling all the lifts at each floor, and there will be only emergency switches inside the lift. The panel at each floor consists of 4 units. A numeric keypad for entering the data regarding the destination floor and the number of persons to be entered, an OK button for confirming these entries, a display unit that will display the lift number that the user must follow to reach his destination, and a busy LED that will glow if all the 3 lifts are busy or if all the 3 lifts are fully loaded. So from the panel, the system will obtain 3 inputs for each call. They are called floor, destination floor, and the number of persons. In our control system, we have mainly 2 units. First one is the parameter calculation unit. So by using the 3 inputs, 3 data that we have entered, this parameter calculation unit will calculate 3 elevator parameters for each lift. The 3 parameters are relative distance, free space, and the vector direction. The relative distance is the effective distance to be covered by the car from its current position to called floor when a call is made. That is, if the called floor is on the way of the lift, then relative distance is equal to 0. Otherwise, relative distance is the difference between the called floor and the nearest destination. Nearest destination is the most nearest floor to the called floor where the lift has a stop. And if the lift is stationary, then the relative distance will be the absolute value of the difference between called floor and the floor of the stationary lift. The free space is the number of persons that further a lift can accommodate after entering the number of persons of this new call to that lift. Here we are calculating free space by considering that a lift can accommodate a maximum of 10 persons. Thus, free space is equal to 10 minus total load minus sum minus of number of persons of the current call, where total load is the total number of persons currently in that lift and sum is the total number of persons getting out from that lift up to the called floor. The vector direction is the quantity used to determine the corresponding direction of the elevator. That is, if our new call is in the direction same as that of the current lift direction, then vector direction Vd is equal to 1. Otherwise, Vd is equal to 0, that is opposite to the current lift direction. The direction of new call can be obtained by calculating the difference between called floor and the destination floor. For stationary lifts, vector direction is equal to 0.5. The elevator parameters that we have calculated for each elevator is then given as input to the second unit of our controller, that is the fuzzy logic unit. And this fuzzy logic controller unit will calculate priority for each lift based on pre-designed fuzzy inference rules and based on this available elevator parameters. And then among the all elevators, the elevator having the highest priority value will be assigned for this new call made. By using this design methodology, we have developed our whole idea in LabVIEW environment. In our simulation working model, we are considering a 10-storied building with 3 lifts. This is the front panel of the simulation working model of our project. Here we can see a building, a 10-storied building model and a 3-lift arrangement, and also panels for each floor. So altogether we can see 10 panels, each panel of each floor. And in a panel there is a provision for entering destination floor, number of persons, and also an OK button for confirming these entries, and a display unit for displaying the lift number to which that person or user have to follow to reach his destination. Then a busy LED that will glow when all the 3 lifts are busy or are fully loaded. So this is the front panel of our system. Okay, now let's look at the working of our system, how this simulation working model will work and how it is exactly selecting the appropriate lift for each new call made. Here we have got a new call from 5th floor to ground floor and lift 1 got selected for that call. While executing that call, there occurred a new call from 2nd floor to ground floor. So here lift 1 is selected for this new call because it can execute this new call on the way of its previous call itself. Now, what will happen if the new call is opposite to that of previously assigned call? Let's see. Here we have got a call from 9th floor to ground floor and lift 1 got selected. While it is coming down to ground floor, and another call from 4th floor to 9th floor occurred. This new call is in the upward direction, but lift 1 is going downward. So it is a case of opposing So lift 2 got selected for this new call even though lift 1 is covering the 4th floor. So this is how our system is selecting aiding lifts, thus making an efficient control. Now let's see the safety aspects of our system to avoid overloading. Here a call has been occurred from 9th floor to ground floor and lift 1 got selected for this call. Here we have 5 persons to enter into lift 1 from 9th floor. While executing this call, we got another call from 7th floor to ground floor. So it is a case of aiding for lift 1. But we have got 8 persons to enter into lift 1. And already lift 1 has 5 persons inside. So a total of 13 persons. So it is a case of overloading since we have a maximum capacity of 10 persons to a lift. So lift 2 got selected for this new call, thus avoiding the condition of overload and thus making our system more safe. Now let's see what will happen if all the 3 lifts are fully loaded or if all the 3 lifts are busy. Here we have all the lifts busy and we are getting a new call from 2nd floor to ground floor. So what will happen? Of course, a busy LED will glow. What will happen if we enter a wrong information? Here a new call is occurring from 7th floor, but here number of persons that is entering is 0, but there is no 0 number of persons. So it is a case of error information. So in that cases, our system will show an error signal, thus making our system more accurate and precise. Now let me conclude about our idea or about our topic. We are hoping that you all got a very good understanding about our idea and about our application that we have made. We are sure that it is a very good intelligent control that is far more better than the conventional method, and we are sure it will save energy and time. We are hoping that our Hiec system will be a Hiec in future. Thank you everyone. Thank you.